Howdy. A quick read through. That's really interesting. 5 hours ago. Those who are familiar with the electric universe theory, the capacitor theory, plasma universe, you might find this really interesting. Key particle weights in a bit heavy, confounding physicists. The grand explanation physicists use to describe how the universe works may have some major new flaws to patch after a fundamental particle was found to have more mass than scientists thought. And haha, how funny, there's a dragon in the commercial. For whatever they are making a commercial for. It's not just something is wrong, said Dave Tobak, a particle physicist at Texas A&M University and a spokesman for the US government's FERMI National Accelerator Lab, which conducted the experiments. If replicated by other labs, it literally means something fundamental in our understanding of nature is wrong. So if I won't read the whole thing, you can read it. Yeah, and what else they use in order to produce these experiments? It is electricity. Where has it been? That also is somehow really interesting to read. Remember, it was the US government making these experiments. Earlier, less precise measurements of the W boson by other teams found to be lighter than predicted. So, maybe there is just something wonky about this experiment. Wonky, said Caltech physicist Sean M. Carroll, who wasn't part of the research and said it is absolutely worth taking very seriously. The finding is very important because of its potential effect on the standard model of physics. Nature has facts, Dukes Cotwell said. The model is the way we understand those facts. Scientists have long known the standard model isn't perfect. It doesn't explain dark matter or gravity well. If scientists have to go in and tinker with it to explain these findings, they have to make sure it doesn't throw out of whack mathematical equations that now explain and predict other particles and forces well, researchers said. So, I would say, if you cannot explain gravity well, you might be wrong in the first place. Or there's something really fundamental wrong with your stuff. If scientists have to go in and tinker with it to explain these findings, they have to make sure it doesn't throw out of whack mathematical equations that now explain and predict other particles and forces well. It is a recurring problem with the model. Ha 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 ha! A recurring pattern. A year ago, a different team found another problem with the standard model and how muons react. Quantum mechanics is really beautiful and weird. Anyone who has not been deeply troubled by quantum mechanics has not understood it. Yes, I have been deeply troubled with quantum mechanics. I haven't understood it because it doesn't make sense. This is what I understood about quantum mechanics. I want to share a quick part of that with you. I recommend you to watch the whole. It's really interesting. Ben Hyde will talk really quickly after.
However, in the 21st century, the public face of space science is less the astronaut than the physicist and astrophysicist. When young people wish to learn of space science, they learn of Big Bang, gravity centric cosmology. They hear of the respective works of Newton and Einstein, and they must try to make sense of concepts such as warped space time, infinities, and singularities. They're told of a universe that is 96% dark, comprised of matter and energy that are unproven, invisible, and, quote, poorly understood. To find that a scientific foundation exists for any different way of seeing the universe, the young and the curious have little choice but to seek outside the confines of institutionalized science and beyond the narratives its celebrity spokespersons promote in popular media. On such a journey, one has a chance to discover that an astounding scientific foundation exists for another cosmology, a cosmology which recognizes it is not gravity that governs the universe, but rather electromagnetism. The forefathers of this cosmology are not named Newton and Einstein. They are the giants of electrical and plasma science, the renowned experimentalist Christian Berglund, and the Nobel Prize winners Irving Langmuir and Hannes Alfvén. A universe filled with electrically conducting plasma is not 96% dark. It is alight with electric currents. And the physical mechanisms that spark the phenomena we see are both understandable and easily replicable in laboratories on Earth. Recently, we spoke with a member of the Electric Universe community who has made it his mission to introduce the young and the curious to the ideas of the electric universe. His name is Benjamin Hyde, and he is a science presenter on the news station Fox 13 out of Salt Lake City, Utah. We asked Ben to introduce himself and to describe his efforts to spark inspiration and interest in the sciences among today's youth.
This is Benjamin Hyde, and I have been studying physics, specifically quantum physics, for the better part of 2.5 decades. It's been a passion of mine. It's something that I love and I really enjoy. And now, 2.5 decades later, I realized that the reason why I was so fascinated with it is because I like understanding the fundamentals of things, reality. And quantum physics, from my old understanding, was that where that explanation was going to come from. I wanted to know what everything was made of. And so I studied it, and I did what everybody in this field did. I just took what was given to me and accepted it. And because I didn't have anything different at the time, I said, okay, this is what it is. And it didn't really dawn on me that it didn't make sense. And if it didn't, I'm just like, well, I'll just roll with it. I remember specifically of years ago when dark matter and dark energy really hit the stage, and I learned that 96.5% or whatever it is of the known universe was either dark matter and dark energy, and I thought, wow, that is a profound amount of stuff in the universe that we don't know anything about. So I justified it in my mind that basically anything was possible because most of what we knew we didn't know. So as I'm studying quantum physics, particle physics, cosmology, I of course ran across videos from the electric universe because I would go to YouTube and I would watch, Brian Greene, the World Science Festival videos, love those for a while. And of course, the Electric Universe videos would pop up every once in a while, and I'm like, great, I'll watch those too. And I did. But what happened, and this is funny, every time I would study physics, I would get to a burnout mode. I would study it for a few weeks and I would just get so frustrated that I just would lose interest in it. And now, looking back on it, I realized that was because I was studying nonsense and I was trying to bang this garbage stuff into my head. And there was a part of my head that was just saying, Ben, this isn't real. This is a mistake. So after one of these up and down times with quantum physics, I went into the electric universe and became enthralled. I learned who David Talbot was. I learned who Walt Thornhill was, and I learned what they had to say, and it was just captivating. And as
And yes, he has mm, the education to say so. I don't. But anyway, it dawned on me. I have. I bought in '99 Brian Greene's The Elegant Universe book. I spent a few years understanding that book. And once I thought that, no, this just doesn't, no, how? Doesn't make sense. If you watch at nature and this kind of stuff and what they are trying to explain, it doesn't make sense at all. What they're trying to explain you stuff which you never will see with your own eyes. Never. Just impossible. And how they are trying to explain the universe, which is all around us, which we are, which is us, doesn't make sense. And now, how interestingly, Phys.org 5 hours ago, key particle weighs in a bit heavy, confounding physicists. Is this a breaking point of the old theory? It literally means something fundamental in our understanding of nature is wrong. Says no lesser institution than US government's FERMI National Acceleration Laboratory. Interesting times. Thank you. Bye.